Hello, welcome back to the third clip about methods in C#. So far we learned about void and non-void methods, return values, variable scopes and method parameters, and I promised you that we'll get into some more advanced topics and also show you that hidden method. But for that we need to do things a bit different when creating a new project. Let's open Visual Studio and create a new project. You already know the steps to do so, so I will not repeat them. The only thing that needs to be changed is to check this option here. Do not use top level statements. So check that one and hit create. As you can see, we are greeted with a completely different project than the one we've been creating. It has this program class and this main thing and so on. This is how an actual console program used to look like until recent versions of .NET. Remember how I told you that C# wraps all your code in a giant main method? Well, here it is. This is the main method, the one that every program must have. It's where your program starts its execution. It's the one that it's automatically called when you double click your executable. So all this was hidden away from you in the previous project. The compiler generated for you automatically and placed all your code inside it. Now that we can see the main method, let's add the method that we had in the previous lesson. For now, just ignore the static keyword. I will explain it in a future lesson. Just know that I need it in order to be able to call add numbers from within main. But what if I wanted to add float values? Obviously, I can't call add numbers with floats. Not only does it expect ints and not floats, but even if I casted the float values to integers, I'd still lose the fractional part, right? So 3.5 plus 3.5 would equal 6, not 7, because we lose the decimal part. Sure, we could start specializing our methods, like one called add ints and another one called add floats and so on, but that would be messy. We'd have a lot of duplicate code just because the data type differs. And let's not even get into permutations like the first one is int, the second one is float and so on. That's already madness. Instead, we can create a new method, also called add numbers, but with different parameter types like this. And now we can call it with float values. This is called method overloading, where we have the same method but with different parameter types or different number of parameters. Because yes, we can have a third method still called add numbers, still taking floats but taking 3 instead of 2. But how does the program know which to select, which to call? Simple. It looks at what type of parameters you call it with and their numbers. If you call it with ints, you obviously meant the int version. If you call it with 2 floats, you obviously meant the float version, the one with 2 floats. If you call it with 3 floats, the 3 floats version, and so on. This combination of a method's name, its parameter types and their number is what's called a method signature, and it's the one that determines if you get an error about a duplicate method or not. As long as two methods have different signatures, they can coexist. It doesn't matter what differs, the method's name, the parameter types or their count. What is not part of a method signature is the return type. If you have two methods both called add numbers, both taking 2 parameters of type int, but one returning int, the other returning void, you will get an error. That's because, as you saw in the previous lesson, it is not mandatory to actually use the return value. You can just ignore it or discard it. So how would the compiler differentiate them? When it's calling them, they both have the same name, they both have the same parameter type and count, and we ignore the return value for both. How would it differentiate them? It can't. Regardless, we've been using method overloads all this time without even knowing it. If I type Console.WriteLine, you will see this drop down right here that says 1 of 18, and if I go through them, you will see variations that take as a parameter a bool, a char, and so on. That's because indeed Console.WriteLine has 18 overloads. That's the reason why you can call it with whatever variable type and it will not give an error. Still related to parameters, what if I want a parameter that is not mandatory? Sometimes you want to call a method with a value, sometimes without. This can be achieved with something called optional parameters, like this. And now I can call it like this, or like this. The explanation is simple. If I call it with 3 values, the third one will be placed in the z parameter. If I call it just with 2, the default value specified in the declaration will be used. Optional parameters have a single rule. Once you declare an optional parameter, only optional parameters can follow afterwards, so you can no longer specify mandatory parameters. We also have local methods, which are methods inside other methods. They look and behave almost the same as a normal method, with some differences, one of them being that they cannot be overloaded. There is also a peculiar behavior of local methods in regards to variable scopes. A local method can actually access the local variables of its containing method. So if I declare a variable inside main and then I declare a local method also inside main, that local method can actually access the variables of main. This is different from regular methods which only see their own parameters and local variables. So as you can see, inner method does access x, which is declared in main. This is a rather advanced topic called closures that we'll discuss way in the future. Anyway, this is also the explanation of why I needed to create a project with a simplified setup. Remember, whether you use a simplified setup or not, you do have a main method. If you don't see one, the compiler generates it for you. And it takes the codes you write and places them inside this generated main method, which means that any method that you write now becomes a local method, which cannot be overloaded. Hence, I couldn't explain to you method overloading without forcing it to use a regular main method. This is one of the reasons why I don't agree with Microsoft's decision of simplifying console programs for marketing purposes, so they can brag that C# can write hello world at the console on a single line like Python does. Yeah, but that comes at hidden complexity that many experienced devs don't know, let alone juniors trying to learn the language. So if you as a beginner trying to learn method overloading would type it out and you'd get a compiler error, you'd go crazy trying to understand what's going on. Anyway, this is another subject and it's a personal preference of mine. You can decide for yourself, of course. In fact, if you agree or disagree, write it down in the comments and let's debate. Civilized, of course. As miscellaneous things at the end, know that in recent versions of .NET we have expression bodied members, which allow us to write methods like this. But I recommend you to stick to a single style and use it consistently throughout your codebase. We also have recursive methods, which are methods that call themselves. I know this sounds weird, but it's a rather important topic and we'll discuss it in a separate video. Man, this was a wild roller coaster. We've covered a lot of ground already. We know about variables, we know about conditional and iterative processing, we know about methods, we can already write semi-complex programs. But to better understand all this, in the next lesson we will have our first debugging session where we'll learn about execution flow and we'll touch briefly on something called the call stack. If this clip clarified things for you, consider dropping a like to help others find this content. And if you're ready to keep building your C# skills, hit the subscribe button too. We've got plenty of programming adventures ahead. Thanks for watching and I'll see you in the next tech frame.